when we talk about environmental installations, I normally think of some NEMA rated enclosure. What else should we think of as we ask for the environmental considerations for a panel?
Well, I think for starters, there's a little bit of a misnomer where NEMA is concerned. Um, so NEMA is kind of a standard, so like a NEMA 4X, a NEMA 12, and that's what most people, at least here in the United States, refer to when they talk about environmental protection. But there's also there's NEMA, but UL, which is which we make our panels to, UL 508A defines it actually as type, which follows the NEMA standard closely, but we do have to make sure that all of our components are actually rated for the type per UL. But there's also the IP standard, which is pretty common in Europe and European Union countries. And so we make to UL 508A. We also have the ability to make to an IP as well, but we typically, if customer asks for an IP, we'll usually just convert to the equivalent UL type rating or NEMA standard. But when it comes to the actual environments, there's really several questions you really need to ask. The first is, where's the panel going? Is it indoor? Is it outdoor? Obviously, those are the big ones, but it's more than just that, because is it outdoor under a shed, or is it outdoor literally open to the sky and the sunlight? Because those are two totally different scenarios when you're designing a panel. If it's under a shed, I don't necessarily need to, although sometimes you still operate on the side of caution, but you don't necessarily have to worry about drip hoods and sunshade protectors over some of your controls. Whereas if it's out direct sunlight, and getting rained on all the time, that's something you would want to strongly consider. But so you've got that, but you've also got the temperature to account for. So if it's outdoors and it's going to be in the middle of summer, there's like a 99% chance that your panel is going to require an AC unit for us to maintain a UL standard on that. So 104 degrees Fahrenheit is the max temperature that we can make a panel in. And that's not the outdoor temperature, that's the inside temperature with all of the power the components are generating inside that panel. And so it's important for us as the UL representatives here at Farnam to make sure that we design these panels to take the temperature of your application. And so that's why it's really critical that we get a good insight on where they're going. And so the other thing that I should say also is so obviously rain and indoor outdoor is important, but also what else is around the panel? So is it near any kind of gases that could be explosive? That's the kind of thing we need to know, because it'll change what UL standard the panel needs to be built to. Or is it going to be around a bunch of acids that may require us to use a type 4X, which would basically be the panel would be all stainless. In addition to being waterproof, everything would be stainless and corrosive protected. So there's a lot of considerations that go into environmental, and it's something people don't always put as much thought into when it comes to control panels.
Well, depending if your facility is climate controlled or not, your facility could be 90 degrees in the summer, and inside the panel you could still need AC. Exactly.
And it depends on what the amperage rating of the panel is too. I mean, a 20 amp panel sitting over there in a corner might never be a problem, but once you start going to higher amperage, all these components, they start dissipating more and more heat, and the heat has to go somewhere. So
yeah, so for every hazardous location, as you were just kind of talking about, spray booths and things like that can come into play on some of this as well. So if we know the classification and division of the hazardous location that the panel will be installed in, that helps us look at different directions that we need to go for the enclosures and whatnot. So,
and I think to consider, are you going to have a user that has to interface with it? How do you want that user to interface? Or how do you not want that user to interface with the panel? Both of those are considerations. You might not want an operator being able to make adjustments. And there are different ways to lock out both physically and electronically.